Hey, it's Professor Dave. Let's talk about scientific notation and dimensional analysis.
He knows a lot about the science stuff. Professor Dave explains.
Humans like to count things. In the first civilizations, we had to count in order to trade goods with one another. Because we have 10 fingers, we based our counting on a system of 10. If we count apples, we can get to 9, but if we add one more, we put a 1 in the tens place and then start building up the units place again. There's a hundreds place, thousands, and so forth. Each time we reach the next factor of 10, we add a digit. But what if we want to talk about a really big number, like the number of molecules in this glass of water, or the number of stars in the universe? It's going to get tedious very quickly to have to write numbers with dozens of digits. We need a way to abbreviate very large and very small numbers. That way is called scientific notation. A number written in scientific notation will always consist of a single digit, followed by a decimal point, and then some other numbers depending on how many sig figs are in the value. That number is multiplied by 10, which is raised to an exponent. What this represents is the magnitude of the number. 10 squared means 10 times 10, which is 100. So 1.42 times 10 to the second is 142. We can get that by moving the decimal to the right twice. 10 to the sixth, or a 1 with 6 zeros, is a million. So 5 times 10 to the sixth is 5 million. We can get this by moving the decimal over 6 times, adding zeros if we need to. We can also discuss very tiny numbers this way. 10 to the negative second means 1 over 10 squared, or 1/100th. So 3.5 times 10 to the negative 2 is 0.035. We can get this by moving the decimal 2 places to the left. And 8 times 10 to the negative 9 will be this number once we move the decimal 9 times. This is useful because now we don't need inches and feet and miles. We can just use one unit and express values in scientific notation. For length we use meters, for time we use seconds, and so forth. Now we can discuss the diameter of an atom and the distance to the nearest star in the same unit, meters, just with scientific notation. We can also use unit modifiers to symbolize different magnitudes. Kilo means 10 to the third, which is 1,000. So a kilogram is 1,000 grams. Nano is 10 to the negative 9, which is 1/1,000,000th. So a nanometer is this many meters. So we can express values with a word to indicate magnitude instead of a specific factor of 10. Here are the different modifiers we use. We can apply them to any unit, and they will do the same thing. To convert between units, we need to do dimensional analysis. Let's say we have a value in meters that we want to express in nanometers. We take the value we have and we multiply by a fraction that is equal to 1. We do this because multiplying by 1 doesn't change the value. But we multiply by a version of 1 that changes the way the value is expressed. We do this by putting things on the top and bottom that are equal to each other. In this case, 10 to the 9 nanometers on the top and 1 meter on the bottom. These are equal because if a nanometer is a billionth of a meter, then there are 1 billion of them in 1 meter. So since these are equal, this fraction equals 1, but the meters cancel just like an algebraic variable, and now we have a value in nanometers. It's the same value we had, but expressed differently. We can do this to convert between any units. Just multiply by fractions that equal 1 until you have the value expressed in the units you want. For example, how many seconds are in a year? Well, let's use some conversion factors we know. 365 days in a year, 24 hours in a day, 60 minutes in an hour, 60 seconds in a minute. All the units cancel except seconds, and we just multiply the numbers to get the answer. These are exactly the same length of time, just expressed differently. Let's check comprehension. Thanks for watching, guys. Subscribe to my channel for more tutorials, and as always, feel free to email me, ProfessorDaveExplains@gmail.com.